Hi, welcome back to the CuSi Sound channel and part 35 in the series all about my Project 12 DIY modular analog synth. In this video we'll have a look at the Susurrus module. I'll explain what Susurrus is in a moment, but the module itself was born out of me choosing the wrong VCO to build the LFO for my sample and hold module. I chose a 4046 chip and it didn't really work that well as an LFO. Now I might be making some fundamental electronics theory mistake there, but as I said from the beginning of this project, I'm not an expert, and after all this time I'm still just a keen amateur. But that doesn't stop me creating things to play around with, and that's what I've done. So what I got was a circuit board with a 4046 VCO on there and a noise generator, and it became pretty much surplus to requirements because it didn't do what I wanted to do for the sample and hold. Well, I don't throw these things away, I just kind of stash them to one side. But then I had a thought, and I thought, right, I've got basically a square wave VCO and white noise. Now on commercial synths I've seen where you can mix in noise with the VCO signal. So that was it. Yeah, it's not a total loss this. I can build another module now which has a square wave VCO with a white noise generator and a mixer section where I can blend the two to get a square wave with noise. Okay, so that's what the module is about. Why Susurrus? Well, I looked up what Susurrus actually means, and it refers to the kind of whispering sound that waves on the ocean make. And I thought, well, yeah, that's pretty much. I'm adding a whisper with the white noise, and white noise can often sound like waves or wind, but I'm adding that whispering to the VCO output. So I thought, yeah, why not? Let's get creative with the names as well, and so the module's called Susurrus because it's a VCO with a whisper. Okay, let's have a look at the circuits. So this is the original circuit that I put together for the 4046 and white noise. So just basically two circuits that I've used before, only this time round I put them on a single board, and the board looks like this. So that's kind of the one that I built, hoping to use it as LFO and noise. In order to be able to use it as a VCO with noise being mixed in, I needed a mixer stage for the output from the two, and so I've just used a bog standard summing mixer circuit. But also on that original 4046 layout I didn't have a CV input, so I also needed to create a CV input. So my second board, it's kind of a piggy-back board, has a CV conditioning section for the CV control on the 4046, and it has the summing mixer which allows me to blend the mixture between the white noise and the VCO. But also, while I was playing around with this, I thought, well, I could actually put some filtering on the noise, because when it's just pure white noise and you mix it in with the wave, the VCO wave, it can be a bit sharp, a bit toppy, a bit harsh. So I wanted to put something that was kind of a low pass filter in there, but I didn't want to start add in more and more circuit boards or components or whatever. So what I've done is I've built a passive low pass filter. I actually just built it onto an extra potentiometer and a capacitor, which is enough to give me a very, very basic low pass filter. I've done these things before with Project 9 way back when I first started. So you can kind of, it's just a common circuit that's you find in any electronics tutorial. I'm rambling on. Okay, so the circuit diagram for the CV conditioning and the mixer looks like this. So it just uses an op-amp chip for both purposes. And the strip board layout for it looks like this. I'm going to put all the diagrams and the strip board layouts in the CuSi Sound Dropbox, and there'll be a link down in the description, so you can go and download these if you want to. And then I kind of wired it all together as the original board plus the piggy-back board, and that looks like this. I mounted it all up on a panel and put it in Project 12. So that's how I built it. What does it sound like? Let's go listen. Here is Susurrus module in the synth. Look at the controls. Pitch sets the pitch of the square wave oscillator, the VCO. CV is the control voltage input for the VCO. The next two controls down are the level controls on the mixer stage. So we've got the level for the VCO output and the level for the noise output. Below the noise we have the cutoff setting for, or the cutoff control for the passive low pass filter, and then finally the output from the mixer stage comes out here, and that's pretty much it. In terms of what I've got set up for the demo, the CV in is coming from keystep controller. Point on that is that this is actually a linear VCO, so it won't be following the 1 volt per octave standard. So yes, like most of the, if not all of the VCOs in Project 12 at the moment, they're all linear. But hey, that's how I play it. So the output from the mix stage goes into a Vactrol VCA, and the output from the Vactrol is going into my patch point changer. More about that in a second. I'm triggering the Vactrol VCA. Well, the gate from the key step, I'm putting it through the gate buffer just to kind of stabilize and boost the signal. It then goes into an envelope generator, and then out of the envelope generator I've got it going into a passive multi, so I can send one copy of the envelope to the CV on the Vactrol, and the other copy is going down to the CV on a ladder filter, because when I switch the patch point changer in this position going onto this output, that is just straight from the Susurrus module straight out into the mixer that is recording the video. But when I flick the switch, I then put the output from Susurrus is going through a ladder filter, and then the output from the ladder filter goes off to the mixer for the video. So the Vactrol VCA and the cutoff on the ladder filter are being triggered by this envelope, which in turn is being triggered by the gate from keystep. Okay, let's listen to some sounds. I'm not trying to play anything. This is simply creating signals for a functional demonstration. So don't expect anything fancy because you're not going to get it. So where I've got the mixer set on Susurrus at the moment is the noise is turned completely off and the VCO is turned down, probably set at about a third. What I have found is that the amplitude, the actual signal strength level of the VCO is much greater than what I'm getting out of the noise, even though the noise has got an amplified section just after the noise generator to boost it up anyway, but it's still nowhere near as strong as the VCO. So you have to play around with those mixer settings to balance things up. And then on the passive low pass filter, it's turned right up, so there's little or no cut off from that filter. Let's have an arpeggio running, and you can hear what the VCO sounds like. That's just a square wave VCO. Let's dial some noise in. You should just be starting to hear the noise kind of whispering in the background there. Bringing more in. That's the noise turned up full. So if you look at the different settings on the mixer knobs, you can see the difference in the signal levels. The noise is all the way around up full, and the VCO is at roughly that angle. Now if I start to turn the low pass filter, you should be able to still hear a bit of the noise in there, but it's lost the top end of it. Now I've not gone very far with the LPF, but I've lost most of the noise. So one of the problems there is I've already been talking about the relative strengths between the VCO and the noise, and the fact that the noise isn't that powerful a signal. That's a passive low pass filter. So the more I turn down the cutoff, not only am I losing some of the higher frequencies, I'm starting to lose some of the overall amplitude of the signal, because it's passively removing parts of the signal, it's just throwing it away. So we're not kind of recovering it in any way. Given that I'm playing around with something that's relatively low signal anyway, in relation to everything else that's going on, I can very quickly kind of lose it. So yeah, using the passive low pass, I mean, the passive filtering is used on the colour of noise module, which has got white noise, pink noise and blue noise. To get pink and blue, they are both passive high pass and low pass filters, and again the signal's boosted to try and recover some. So whether I need to do more boosting after the filter, I don't know. It's something to think about if you're really concerned about that, but it's just, I'm just playing around with it. I'll find out what works for me. Okay, so that's what you've heard there is the straight signal, and a fairly sharp attack and release on the envelope. Let's switch it over to a filtered signal, and we'll start the arpeggio running again. So that's with the noise turned up full. Start to back the noise off. kind of adds a bit of grittiness to it, and the fact that the noise is being filtered as well is that as it closes the cutoff, as it closes the filter, you can hear it taking some of the noise out. Let's turn the cutoff up a bit. Put it back down again. I quite like that. The way it's where the noise is. Of course, if you want some real atmospherics, you can always dial in a little bit of reverb. So with the grittiness of the noise and the sharpness of the square wave oscillator, a bit of filtering, a bit of reverb, things are getting. I'm turning the release up on the envelope now. Back up some of the reverb. Turn the reverb effect all the way off. Come out of the filter. I'll put a bit of slope on the attack there. Go back to the filtered version. No, I actually quite like the straight version. Well, that's a very basic demonstration of my Susurrus module, square wave VCO with a mix of white noise whispering, Susurrus whispering. If you want to play around with mixing noise and VCOs, then yeah, I've given you the circuit diagrams, I've given you strip board layouts, so go on, have a go, build your own.